All right, hey everyone, and a massive welcome to all of our brand new QA interns joining the team today. I am absolutely thrilled to be guiding you through today's explainer. As you step into your new roles, your main job is essentially to break things before our customers do. And to pull that off, you're going to rely on a primary roadmap for ensuring software quality. It's called the STLC, or the Software Testing Lifecycle. We're going to take you step by step through the whole journey of a software feature from its very inception to a flawless release. Okay, let's quickly map out our agenda. We'll start with the intern basics, move right into requirement analysis and planning, developing your test cases, setting up the environment, execution and test closure, and finally, we'll wrap up by looking at some real company QA workflows. Let's dive in. Starting off with Section 1, STLC, the QA Intern Basics. So what exactly is the software testing lifecycle? Well, the STLC is essentially a highly structured, step-by-step pipeline used by quality assurance teams to ensure software quality from start to finish. It's the core framework that every single QA tester, from the newest intern to a senior director, relies on every day. We don't just randomly click buttons and hope the software breaks, no way. We use this systematic approach to intentionally find vulnerabilities, prevent disastrous bugs, and avoid incredibly costly software launches. It is literally your ultimate playbook. And this playbook operates in 6 core chronological phases. You start with requirement analysis, move into test planning, then test case development, followed by environment setup, test execution, and finally, test closure. Every single project you touch during your internship is going to flow through these exact steps. Let's break them down. Moving right along to Section 2, requirement analysis and planning. This covers phases 1 and 2. This is the very beginning of the pipeline. And what's fascinating is that testing actually kicks off long before a single line of code is ever written by the developers. Phase 1 is requirement analysis, which is all about figuring out exactly what needs to be tested based on stakeholder needs. As an intern, your very first job on a new project isn't actually testing, it's reading. If the login button is supposed to, say, lock a user out after 3 failed attempts, you need to identify that rule up front. You're asking questions, you're finding gaps in the logic, and you're figuring out the what of the entire project. Imagine one of our senior QA managers telling you this on your very first day. A bug found in execution costs 10 times more than a bug found in planning. Seriously, this is why Phase 1 is so absolutely critical. Think about it. If you catch a logical flaw while you're just reading over the requirements, it costs nothing to fix a typo in a Word document. But if you miss it, the developers build it, and you find it weeks later, well, it costs the company massive amounts of time and money to rewrite. So the crucial point here is understanding the difference between the first 2 phases. Requirement analysis is all about understanding the what. What are we testing? Once we know that, we move right to Phase 2, test planning. This is strategizing the how. Your QA lead will step in and determine the overarching strategy. Do we need more automated or manual testers? What's the timeline looking like? What are the risks? Simply put, Phase 1 gives you the target, and Phase 2 builds the map to actually get there. All right, Section 3, developing your test cases. This brings us to Phase 3. This is where we take that overarching strategy and we turn it into actual, actionable testing scripts. Once the plan is locked in, you and the rest of the QA team will sit down and write step-by-step scripts for validation. A test case is basically a set of precise instructions designed to verify that a specific software feature functions exactly as it was intended to. You are creating the exact path you'll walk down later to prove the software works perfectly, or to prove that it breaks. Let's look at a practical example of a standard test case document in a real corporate workflow. It requires very specific components. First, you define the inputs, for example, typing admin into a username field. Then, the execution steps, something like click the submit button. Next up, the expected results. In this case, the system should redirect to the user dashboard. And finally, you leave a blank space for the actual results, which you'll actually fill in later when you run the test. It's highly detailed and strictly structured. Next up is Section 4, setting up the environment, Phase 4. Okay, Phase 4, environment setup. This is a critical preparation phase where we create the technical sandbox where all the magic and the breaking will actually happen. Look, you can't just test enterprise software on your personal laptop standard browser and call it a day. Before executing any tests, you must configure the precise hardware, software, and networked conditions required by the test plan. You're building the exact environment needed to mimic the real-world conditions the end user will experience. To give you an idea of a real company workflow, environment setup for a junior QA team member can entail some heavy lifting. It might involve configuring dedicated test servers so you don't accidentally crash the live website. It definitely means setting up isolated databases populated with dummy data so you're not messing around with real customer information. It also involves installing specific target browsers or prepping various mobile devices, making absolutely sure you have an iPhone 12 running a very specific iOS version, just because that's what the stakeholders require. Which brings us to Section 5, Execution and Test Closure, Phases 5 and 6. All right, Phase 5, Test Execution. This is the most action-oriented part of the explainer, where we finally run the tests. This is what most people picture when they think about QA. You take those step-by-step test cases you developed, you open up the sandbox environment you built, and you run the scripts. You enter the inputs, follow the steps, and compare your actual results against the expected results. And crucially, when the software breaks, you log those defects clearly so the developers can actually go in and fix them. But wait, that raises a really important question. How do we know when the testing process is actually done? I mean, hypothetically, you could test a complex piece of software forever, right? But in a corporate workflow, we have strict deadlines. So how exactly do we bridge the gap between actively hunting for bugs and officially wrapping up the entire process? Well, the answer is Phase 6, Test Closure. Once the testing cycles are complete and the critical bugs are fixed, the team steps back and evaluates the success of the testing cycle. This involves analyzing the overall results. Did we hit our quality targets? It also involves documenting lessons learned. What can we do better next time? And finally, we create closure reports to officially sign off on the release. It's essentially the formal handshake that says QA has done its job and this feature is totally ready for the real world. Finally, Section 6, Real Company QA Workflows. Let's bring all these concepts together and see how these 6 phases flow seamlessly in your everyday corporate environment. Whenever a new feature is assigned to your team, you'll start by analyzing the requirements. Then, the team plans the resources. You'll sit down and write the step-by-step test cases. Next, you'll configure the specific test environments. You'll execute the tests and log the bugs. And finally, you will review and close the project. It's just a continuous, logical loop where every single step builds a necessary foundation for the next. As we wrap up this explainer, I want to leave you with one final thought to mull over. Which phase of the software testing lifecycle are you going to master first on your QA journey? Will you become an eagle-eyed requirement analyzer or maybe a master at configuring complex testing environments? The entire STLC is right there waiting for you to explore and conquer. Welcome to the team, grab your project requirements, and let's get to work.